first.
All right. Hi. So welcome to tonight's video. We're going to be talking about section 2.8, and in 2.8 we are going to be talking about inequalities and their graphs. And I have quite a number of guest students here with me today. So let's see. Let's introduce yourselves.
Hey, I'm Devant. I'm Henry. I'm Ryan.
I'm Matthew.
All right, and so these sixth graders are going to kind of help me as we go through it. Actually, I really miss interacting with the class as we've been doing these, so this should be a lot of fun. All right, so what we're going to do today is we're going to talk about inequalities. Okay, we're used to dealing with equations, so things like x plus 4 equals 7. Okay, all we have with an inequality, we talked about how an equation, okay, always has an equal sign. So an inequality, what we're going to do is we're going to replace that sign, and we're going to replace it with a inequality sign. So in this case, let's replace it with less than or equal to. Okay, it's the same idea. It's a mathematical sentence, but instead of having balance on both sides, here we have the left side being smaller than the right side. That's all there is to an inequality. Okay. Now, we can solve inequalities exactly like we solved equations. And I'm getting a little ahead of myself, but this is the most fun thing to do with inequalities. So if I have x plus 4 is less than or equal to 7, I can get rid of that plus 4 by subtracting 4 on the left. And just like before, opposites and balance are still going to apply. And I'll get x on the left side when the 4's cancel out, and I'll get less than or equal to 3. Okay, so that's really what we're building up to. But before we get ahead of ourselves, let's just talk about inequalities. Okay, so with inequalities, we've got a couple basics that we need to learn. Okay, so first of all, we have really 4 major inequalities. We have x is less than, Matthew, pick a number.
5.
5. We have x is less than 5. We have x is less than or equal to 5. We have x is greater than 5. And we have x is, what do you think?
Greater than or equal.
Right, greater than or equal to 5. And actually, there's one more. We're not going to talk about it as much today, but there is one more in inequality. We can also say x is not equal to 5, meaning it could be anything other than the number 5. So we're not going to worry too much about this one today. But all of these up here, let's take a quick look at them. The top one means things that are strictly smaller than 5. So would 5 work? Well, not exactly, because 5 is not actually less than 5. But if I look at the second inequality, 5 would work, because it's everything from 5 and all the numbers smaller. Now, what we're going to do with each of these is we're going to graph them on a number line. And graphing them on a number line is actually kind of cool. What we're going to do is we're going to draw little number lines, not a big fancy thing here. Okay, we're just going to put the number right in the middle, so we'll put 5. And where are all the x's that are less than 5?
On the
Well,
side.
on the left.
Yeah, those are going to be on the left. So what we're going to do is we're going to do, since we're not including 5, we're going to put an open circle on 5, and we're going to shade all the things and make it a really super ridiculously fat arrow. Okay, all the things to the left of 5, and that is a graph of that inequality. Okay, now, very, very, very close to that, I'll make this a little bit smaller so we'll fit them all in here. Okay, if I do x is less than or equal to 5, the only difference is when I draw the circle, I'm going to fill it in. And the difference between these two graphs, we're still going to do the big line, and I'm not kidding, literally draw about 7 or 8 lines, make it really, really obvious. Okay, notice the difference between these two graphs. One has an open circle, and the other one has a closed circle. And just think about what that means, okay? The closed circle means 5 counts, and it's everything left or less than 5. Whereas the open circle says start at 5, but don't actually include 5. All right, obviously, if I go the other direction, if I go the other direction, I'm going to do the same thing. I'm going to draw a number line. I'm going to put a 5 down. If it's greater than 5, it's an open circle on 5. And this time I'm going to be shading all the things that are bigger than 5. And so I think you probably know where we're going with this. If I do greater than or equal to 5, we'll do a closed circle on 5 because we're going to include 5, and we're going to shade everything to the right. Okay, so when you have inequalities, a lot of times it'll say write an inequality and graph the inequality. And so clearly these things are the graphs, and the things in the left, in the black, are the inequalities. This final one that we're not going to really talk too much about, x is not equal to 5, that one's actually kind of interesting if you look at the graph. And again, we're not going to study this too much, but by the way, you can put the 5 on top. What we're going to do for this one is we're not going to include 5. So we're going to put an open circle on 5, just like we did for greater than or less than, and we're going to shade everything on both sides. So it's basically saying, look, What x can be is, right, it can be anything on the number line except
For
that
5.
open circle of 5. Right, that's it. Okay, so that's the basic graphs. Okay, and that's what you're going to be doing in class tomorrow is we're going to practice graphing. Let's just make sure that we can do this. Let's go the opposite direction. Suppose I draw a number line, okay, and let's start this one at -3. We'll put an open circle here. I'm going to shade over on this side right here. And one thing I didn't do on the other ones, because they were all x, we usually put the variable that we're using always on the right, which doesn't kind of make sense. This one shaded to the right, so that kind of makes more sense. Even at the arrow pointed to the left, we still put the variable right here. Okay, it's just how we do it. So what inequality am I showing here? This is the set of y's that are what?
It's greater than.
Right, it's all the y's that are strictly greater than, not equal to. Why do we know it's not equal to?
Because the circle's not colored in.
Right, the circle's not colored in, so it's y is strictly greater than -3. Okay? Let's do another one. That was fun. All right, what about this one? Let's do a fun variable. Let's do z. Okay, so this, the variable, and again, notice what I talked about before. Okay, we always put the name of the variable over here. It just always goes on the right. That's just the naming convention that we use. And that one's kind of ugly, so I don't like Z. Let's pick a different color. Let's use R for Russo. All right.
And Ryan.
And Ryan.
And Ronald McDonald.
Okay, thank you for that contribution, Henry Beck. Okay, so what inequality are we looking at here? We're looking at all of the R's that are what?
That are
To the equal and less.
Right,
Less.
they're to the left of 4, so that's less than or equal to. Why is it equal to? Because it's
the
filled.
circle's filled in.
The circle's filled in. So this is the set of all R's that are less than or equal to 4. That's it. That's all there is to this. Okay. Now there are some word problem versions, and we'll talk about those more in class. But this is really pretty self-explanatory. Let's do one real-life example. If I'm driving on the Lexington city streets, you'll see traffic signs that basically... Whoops, I wanted that to be black. Let's try that again. Okay, you'll see traffic signs in the various Lexington neighborhoods that basically say speed limit. And what is the neighborhood speed limit? Not when you're on a big street, but if you're on a little side street, it's 25. What does that mean? That your legal speed S has to be what?
25 and less.
Or 25 or less.
25 or less. So what we're really saying is to be legal, you have to be driving at a speed of less than or equal to 25, and we'll just put a label in there, miles per hour. Okay. Now we know that really if you drive down the street at 28, they're probably not going to pull you over. But to be totally legal, you're supposed to be driving less than or equal to, it's totally fine if you drive the speed limit, you're just not supposed to go any faster than that. So less than or equal to 25 miles an hour. And so that's just a real life example of where we see inequalities. All right, that's it. That's 8 minutes of video. We'll practice these in class tomorrow. So thank you very much for tuning in.